All right, so good evening, guys, and welcome to today's class. Yesterday we explored um, a simple agent making how the understanding the state, the nodes, the graph, and then how you can build the graph and it will be executing from one node to another, and we're able to make LLM calls with line chain, and then we were able to integrate this line chain into a graph. So today we'll be taking a step forward from what we did yesterday. We'll be taking a step up, and in that step up, so let's have like a quick review from what we did yesterday. So, quick review, um, initialized with our visual environment. We initialized the LLM. So we are working with GPT 4.1 Nano. So the GPT 4.1 Nano is very fast and very affordable. All right. So I think it's around either 0.1 or $0.2 for 1 million tokens. So it's very affordable, but it's not that smart. 4.1 is smarter than 4.1 nano. And also have the recent one, which is 5.1 and 5.1. 5.1 has zero point 0.1 million and zero point 0.1 nano. All right. So, and just like we did yesterday, you can actually make a query and then you get a response, which we can continue to maybe manipulate this response to just you can say print to get the actual response. You say response dot content. All right, and then we get the actual content. So you look at it, see that this is a markdown. All right, so we went further to actually build a simple graph. All right, so this is a simple graph. We have our prompt, made our different import from the LangGraph graph. We imported state, start, and message state. Message state is the state schema that we are using. All right, so and we imported the human message and then the system message. We declared our prompt, added it to system prompt. All right, and then we defined our node, which is a function. Okay, so the function is it takes the state, which are the messages, make an LLM call, and then update it back to the state. So, and we initialize the state graph, added the node. Okay, so added the node, the LLM call is the node, and then we built our simple graph. So this was just what we did yesterday, and we had a simple graph like this. All right, so and if we have a call, this graph is to guide you on using VS Code. So if you want to make a call, you can say query is equals to let's just say who are you, and then a message. All right, and we say graph. So and then we'll be able to print the response that we'll go to say for in response of messages So I'll say m the pretty print. Okay, I think oh, okay, this is an error here. Okay, all right, so this is just pretty much what we did. So I can ask it some, let me just say who is Trump, and you will see the response. You say that okay, it can only assist you with VS Code because of the instruction we gave here. So this is just literally what we did yesterday. All right, so now we are taking this thing a step further. I want to add tools to this agent. So what is a tool now? A tool is just like a function, all right, that can actually perform a particular task. So a tool is just like a function that can perform a particular task. So you pick this tool and then add it to your um, agent, which is your LLM. You bind it to your LLM. Now, what is this tool? Let's take, for instance, I'm going to use mathematical operations. Let's say that we know that if you actually give the LLM some mathematical operations, it will perform it. But let's say it doesn't have that knowledge to actually perform some mathematical operations. All right. We can build functions that can actually perform these mathematical operations and then give it to this LLM and tell it that, oh, you have this and it can do this, you have this and it can do this. Then, whenever it sees a task that is related to those things that it has the tools, it's going to go ahead and make use of the tools it has to execute those things. I don't know if I'm making sense. All right. So, for instance, here we'll have I have two functions here, the multiply and the add function. So these two functions are just simple function to take two integers, multiply them, return the product. This one take two integers, return the sum. All right. So these are tools. All right. So to define a tool, you need to add a decorator. It can actually work if you do not add this decorator, but best practice, you need to add a decorator. If you add this decorator, then it will be able to recognize this as a tool and know, okay, this is a tool. So that is the essence of adding this decorator here. So this is a LangChain decorator from LangChain core.tools. You can add this decorator. All right, so but let me show us something now. Look at this multiply. This is a function, but if I type this function now, you see that it already has some functionalities with it. I can add invoke to it and it's recognizing this just because of this decorator. So it's already seeing this as a tool in this my code. All right, so let me recap with what I said before. Let's take, for instance, that this LLM doesn't have the feature to perform these arithmetic operations now. We can define them as a tool, and then we are going to add it to the LLM. All right, so I believe we understand this function here. It's a very simple function just to perform multiplication, this one to perform addition. All right, then we'll just make a list of those functions. We'll call it tools. Tools is equal to, this is a list of the functions. All right, then what we need to do is we're going to bind this tool to our LLM. Remember, we have declared our LLM here. So look at our LLM. All right. So we are creating another instance of this LLM. We called it LLM with tool. I will say is equal to LLM.bind. This dot bind is a member function. Okay, in the that comes with LangChain in the part of the class for the LLM initialization. So we'll say dot bind and we'll pass the list of those tools that we have added to a list. So with this now, this variable now is our LLM, but it already has these tools binded to them. Let's continue now. So I just created a simple system prompt here, telling that will be telling our agent that it is an assistant to solve arithmetic operations. All right, so this is our system message. Now this is our assistant, just a simple node that makes LLM call, just the basic things that we know. All right, so you get the state, okay, then your response is equals to. Now if you are trying to make the invocation, you will not just use this LLM, you will use this one that has the tools. All right, because you want it to make use of the tools. You use this one that has the tools to say LLM with tools.invoke, and then you pass your message, which is your system message, and then list of your messages. You add the response to the state as well, and that is just it. So let's build the graph now. Building the graph, there are a couple of things that you need to import. All right, so now look at how our nodes were added. This particular one, we are conversant with this. We looked at this yesterday. So this is just what we learned yesterday on how you can add a simple node. Now look at what we did here. We are adding another node, which is tool, and we are using a class from LangGraph, which is the tool node. So this tool node prepares our tools in a node. All right, no matter the number of tools we have there, it prepares them in a node. That's why we have the tool node here. I will name the tools. All right, so you can define your own custom tool node, but that is a bit advanced. So, but we are using the inbuilt that came with LangGraph, all right, so which is called the tool node. So we're using this tool node to package our tools. So remember, this tools is a list of all the tools that we have. I will package them as a node and we'll added it and we'll call it tools. Now let's build our edge. So building the graph now, we'll start from start to assistant. All right. Now from assistant, we are calling a conditional edge. Now, remember that yesterday we defined our own conditional edge, but here now we are using a two condition edge. This is a conditional node, all right. So, but it is called a two condition. This one now is comes inbuilt with LangGraph as well. So you can define your custom own, but we are using the one that's come from LangGraph. All right, so you add the conditional the two condition. All right, so this conditional function here. So what this thing does is it returns two things. If the LLM made a tool call, it's going to return tools, but if it did not make a tool call, it will return end. So that is just how it works. If it made a tool call, it will return tools. If there was no tool call, it will return end. All right. Then if it return tools, that means it's going to call our tool node. So after calling the tool node, is then we are now telling it, okay, if tool was called, execute from tool to end. All right. So we are going to build and compile this so that we'll have a look at this graph. Now, having a look at this graph will help us to understand this better. Name tools was not defined. Okay, I have not run this. Okay, then this should go now. All right, now have a look at our graph. Now, when you're having a look at this graph now and having a look at what happened here, you should be able to understand this better. We went from start to assistant, and then from assistant we went to a conditional node. Remember, this dotted line is showing that there is a conditional edge here. There is a condition here. There is a condition that is executing at the background, which is this conditional function here. Okay, So once it executes this condition, and this condition returns truth, is going to come to truth. But if this condition returns end, it will come to end. Now we are telling it anytime the condition returns true, please go from true to end. Then from true, it will come to end. So we'll just build something that is just very simple and basic. Now let's execute this now. Okay. Um, okay, this is me asking a question here now. So like I asked you, what can you do for me? So let's execute this. And it told me that it can assist me with arithmetic operations. Good and fine. Something happened here. I'm going to explain it. I'm going to explain it. But before I run this explanation, let's run this now. Let's say, what is 6 multiplied by 5? Now, you see that the response now is quite different. Now, look at what happened here. The AI message made a 2 core. There was a 2 core. Are you with me? And then that 2 core, this was the argument. It passed 2 arguments, 6 and 5. And the 2 it called was multiply. Do you understand? It called the 2 called multiply, and these were the arguments 6 plus 5. 6 and 5. And then our 2 message now returned, this was the 2 that returned this answer now. Multiply 2 now returned 30. So this particular 2 now returned 30. Now, if we go up here now, we'll see that this is our multiply. It takes 2 arguments, A and B, and it returns their product. Just as simple as that. So this particular LLM call, now when I performed this LLM remembered that, this guy is trying to perform arithmetic operation, and I have tools that can perform this. Now it's now called the appropriate tool to perform that exact arithmetic operation. Remember, I have 2 tools here. I have 2, 1 and 2, but it was able to call this because it knew that this is for multiplication. All right, so let me run addition here now and execute this. So you see that it still made a 2 core, but it called the addition 2 because it understood that, oh, these guys want to make additions here, not multiplication this time around. All right. So, but what if I ask it another question now? Let's say the first question that we had here before, say, what can, okay, this is what I will do now. Okay, this is what I have here. This is what I had here now. So I'm going to pick this and run it here now and say, what can you do for me? I want us to compare these two. All right, now look at this. You will understand that this particular, in this execution, it went from the input and it gave you a response directly from the AI message. It did not call any tool here, but here it called a tool. This is to tell you what actually happens here. Now, when this assistant receives this information, now it passes an output. Now, its output is in 2 ways. Its output is this AI message. Now, this AI message goes directly to this function here. Then this function checks what this man sent to me. Does it contain a 2 core or is it just a direct response? If it is a direct response, it returns to end. But if it is a 2 core, it will pass it and execute the actual tool that is supposed to be executed. This is just the simple way that this thing works. I believe I was very basic here now to actually explain this. So before we before we take another step forward, if you have a question, maybe you can ask, and then we'll continue from there. So we are going to take another step forward in building this thing now, in adding something else to this now. So if you have a question, you can raise up your hand or you unmute yourself and take the floor.
Good evening, sir. Thank you very much so far. The question is, the comments that comes, the multiple line comments that is on this the multiply function, is it actually needed, or can we still define the functions without putting those comments?
Okay.
Does the comment in any way helps the
Okay. Yeah, that was a smart one. I was expecting that. I purposely skipped it, but I was going to explain it later because everything we will be doing here, you are going to see it. It is called a doc string. Okay, it is called a doc string. Now, a doc string is necessary when you are defining your tool because it helps the LLM to understand what that tool is doing. Now, there are two ways you can help the LLM to understand the tools you are giving it. One is the doc string. Okay, it understands what the tool does. Now, two is at your prompt. Okay, at your prompt, you can explicitly explain certain things here so that the LLM will understand, okay, this is how the tool is expecting me to respond to it. And you also ensure that you have your doc string here. If I remove this doc string here, with this my decorator here, it's going to raise an error for me. But if there is no decorator here and I remove this doc string, it might not raise an error. All right, so but this doc string is very essential in your tool because it's part of what that explains to the LLM, okay, this is what this man is, or this is what this man can actually do. All right, so I believe I'm clear, Clement.
Yes, sir.
All right, Adesanwo, I don't know if I was right with the pronunciation.
Yeah, you are correct.
Okay.
Thank you so much for your time. I'm sorry I'm chanting, but I just need to ask this question. One, I wanted to know whether this line of code, can it run without internet, or do we need internet for it to run?
Okay. It needs internet to work. Okay. Now, this is why it needs internet. This place that we are trying to call the LLM, okay, you are making a query directly on the OpenAI server, and it's going to give you a feedback. So you need internet access, a strong one for that matter, so that it will improve the latency. So if you have a weak internet access, it's going to affect the latency. Like when you watch, you see what we're having here, 2.8 seconds, very fast, 2.6 seconds, and all that. Some we even give you lesser than this. So, but if you have a weak internet access, it's going to take more time. So,
All right, thank you so much, sir.
all right, you can.
Let's ask, after working on this AI, is it possible to deploy it on something like WhatsApp, like a chat on WhatsApp?
Yeah, you are thinking like a developer now. Of course, if you can integrate WhatsApp to it.
Okay, thank you so much, sir.
You're welcome. Okay, so we're going to take another step forward. Now, when you look at what we did here now, you see that this we are just having just 11. This is not the type of response we want actually. We want something that's a bit more defined. we need something that is good. So when you watch it, you see that the tool is just returning the tool message directly. Doesn't make sense. So let's make